Hello, this is our presentation on Bernoulli with Zach, Michael, Matthew, and Caleb. So Bernoulli was born in the Netherlands and studied at the University of Basel in Switzerland. He worked and taught in St. Petersburg, Russia, and was part of the lower to middle class. Some of his major contributions include the Bernoulli equation. He developed equations in probability and in political economy, and paved the way for laws about ideal gases. He also won awards in astronomy. His most well-known equation, the Bernoulli equation, means that with an increase in speed, there's a drop in pressure and vice
versa. Question number 3 asks for an interesting story from his life. So as a dying wish, Bernoulli asked that the logarithmic spiral be engraved on his tombstone with the phrase, "Although changed, I rise again the same." That can be seen on the bottom of his tombstone here. Unfortunately, the mason engraved the wrong type of spiral. He engraved the Archimedean spiral instead of a logarithmic. So the Archimedean is seen over here. It has the same amount of spacing between each spiral. The logarithmic is below, and this is important because the logarithmic spiral symbolizes life after death, while the Archimedean spiral is just a unique math.
Question number 4 asks about the spiritual beliefs of the mathematician and how they lived out their faith. Not much is known of Bernoulli's specific beliefs, but it is known that he was born into a family of strong Calvinists, so we can assume he was a Calvinist. His family was so devoted to their religion, in fact, that they fled Spain in 1567 and went to Basel, Switzerland. They fled because at that time, King Philip was sending his army around Spain to find and punish those who were opposed to his rule and to the strict adherence of Roman Catholicism. The Bernoullis decided that they would rather flee than conform to this religious oppression. We can also assume that Bernoulli was a man of faith when we look at his involvement at the University of Basel. He returned to the university to teach, and he had a heart for those who could not access education due to a lack of resources. This is why he led the construction of a pension at the university that sheltered students who would otherwise not be able to afford their living costs while going to school. He funded this program all the way up until his death. Throughout his time at the university, he also made sizable donations to help pay for new books for the school's library and equipment for its laboratories.
So the proof of Bernoulli's inequality. Bernoulli's inequality states that for an integer r greater than 1 and a real number x greater than -1, the sum 1 plus x to the power of r is greater than or equal to the sum of 1 and the product of rx. We'll prove this by mathematical induction, the first part of which is to take a basis step. So for the basis step of r equals 0, we show that 1 plus x to the 0 power is greater than or equal to 1 plus 0 times x. This is true because 1 is greater than or equal to 1. We also take a second basis step with r equal to 1, and this is shown to be true. It evaluates to 1 plus x is greater than or equal to 1 plus x. The reason we are taking 2 basis steps will be evident in a moment. This is the inductive hypothesis. We assume that the equation we're trying to prove is true for some value k being an integer greater than or equal to 1. It's basically just r. And we want to show a k plus 2 step is true for this equation. Now, choose k plus 2 because we can do that because we have 2 basis steps. If you do k plus 2 from the first basis step of r equals 0, you'll get to r equals 2. And if you do from r equals 1, you'll get to r equals 3. And thereby you can get every value of r. The inductive hypothesis is what we start with for our proof. We start with 1 plus x to the k power greater than or equal to 1 plus xk. And we take the next step of multiplying both sides by the square of 1 plus x, which directly simplifies the left half into our k plus 2 step we want to show. The right side, we have to do algebraic expansion on to get a sum of terms, which we then organize to find the k+2 step of the right side. However, there's a number of leftover terms. We will subtract those out, which we can do because this is an inequality. So all we have to do is prove that the terms we're subtracting are greater than or equal to 0, which means that they will make that side smaller, which is legal for an inequality. And this is the proof that those terms are indeed less or greater than or equal to 0. We substitute in the smallest values of x and k for those terms to make the entire term as small as it can be. And when those are substituted in, the entire term evaluates to 2, and 2 is greater than or equal to 1. And therefore, this is a legal step to make. Therefore, the equation is proved by mathematical induction.
Question 6 asks whether or not we would consider our mathematician to be a good role model as we begin looking at a career in mathematics. We personally would not consider Bernoulli to be a good role model as we start looking towards our careers, because Bernoulli sacrificed a healthy relationship with his parents for the sake of his career, and then after attaining his choice career, he sacrificed a healthy relationship with his brother as a result of jealousy. Furthermore, while Bernoulli excelled in his career, he chose to actively avoid a life in which he lived for Christ. This is not something that we desire for ourselves.